Let's solve few problems based on whatever topics we have done so far. Let's start with the first one. See, the first one, you have to prove sin 5x plus sin 3x by cos 5x plus cos 3x is equal to tan 4x. It's a very simple problem, very direct. Now, let's start with the first one. Sin 5x plus sin 3x. This is of the form sin c plus sin d. Correct? Now, what is sin c plus sin d? Recall, it is 2 sin c plus d by 2 cos c minus d by 2. Correct? So, in place of c, we have 5x. In place of d, we have 3x. So, we are going to get 2 sin 5x plus 3x divided by 2 into cos 5x minus 3x divided by 2 whole divided by cos c plus cos d. 2 cos c plus d by 2 cos c minus d by 2. Correct? So you will have 2 cos 5x plus 3x divided by 2 into cos 5x minus 3x by 2. 2 and 2 cancels out. Now here the numerator becomes sine of, see, 5x plus 3x is 8x. 8x by 2 becomes 4x. Sine 4x into 5x minus 3x is 2x. 2x by 2 is just x. Sine 4x into cos x by cos 4x into cos x. Cos x cancels. What is sine 4x by cos 4x? Tan 4x, which is nothing but the answer for the first one. So we can prove this. Let's look at the second problem now. See the second one, you have cos 4x plus cos 3x plus cos 2x divided by same thing. Now, whenever you have these three trigonometric functions, always remember, take the first one and the last one. Now, the reason why we are doing this is when you take 4x and 2x, what is the average of 4x and 2x? It is 3x, right? Something which is there in between. So you can take common. That's why always start by the first and the last term, or more like an extreme terms. Fair enough? Anyway, now see for the second one, what you have will take cos 4x plus cos 2x together plus cos 3x by do the same thing in the denominator also. Sin 4x plus sin 2x plus sin 3x. Alright. Now here cos 4x plus cos 2x. This is of the form cos c plus cos d. Correct? What is cos c plus cos d? Recall again. 2 cos c plus d by 2 cos c minus d by 2. So here it's going to become 2 cos 4x plus 2x, 6x by 2 into cos 4x minus 2x, which is just 2x. 2x by 2 plus cos 3x divided by 2 sin c plus sin d. 2 sin c plus d by 2 cos c minus d by 2. Correct? So 2 sin 6x by 2 into cos 2x by 2 plus sin 3x. Now here you can take, see, 2x, 6x by 2 is nothing but 3x. So here you can make this as 3. Here also you can make this as 3. Now, don't you think you can take cos 3x here and here common? And here sin 3x you can take common, right? So that means the same problem, we can write this as in the numerator, you can take cos 3x common into, you'll get 2 cos x plus 1, because 2x, 2 and 2 cancels, 2 and 2 cancels here, right? divided by, next you can take sine 3x common into 2 cos x plus 1. 2 cos x plus 1 cancel. Cos 3x by sine 3x. Answer is cot 3x. So the answer is going to be just cot 3x, which is there in the proving part. Fair enough? Now let's do the third one, very similar to this one. See the third one? Sin x minus sin y, sin c minus sin d formula. What is that? Is what? Nothing but 2 cos c plus d by 2 into sin c minus d by 2. Correct? So here you have sin x minus sin y by cos x plus cos y. So this becomes 2 cos x plus y by 2 into sin x minus y by 2 divided by 2 cos x plus y divided by 2 into sin x minus y divided by 2. This and this cancels. Directly you will get the answer tan of x minus y by 2. This was rather a simple problem, correct? Now in all the three whatever we have done, what did we do? We used the transformation formula, correct? So we'll do the next set of problems now. There also you have to apply transformation itself, but a little bit different type of problem. All right. Now let's do the next set of problems. See the fourth one. Here sine 2x plus 2 sine 4x plus sine 6x is equal to something you need to prove. Again, what did I tell in the last part? Always start by taking the first one and the last one, correct? Here also we'll do the same thing. Now here for the fourth one, take sine 6x plus sine 2x plus 2 sine 4x. Keep this aside. Sine c plus sine d, which is 2 sine c plus d by 2 cos c minus d by 2. So you will get 2 sine c plus d, 8x divided by 2 into cos 4x divided by 2 plus 2 sine 4x. Now here you can make this as 4, here you can make this as 2. So what you have? 2 sine 4x cos 2x plus 2 sine 4x. Correct? What do you see common? 2 sine 4x is common, isn't it? Into cos 2x plus 1. Now you might be thinking, okay, now how do we go about this? Because the RHS has cos square x, sine 4x and everything. Sine 4x we already have. You don't have to worry about that. But we need to get that 4 cos square x somehow, isn't it? Now what we'll do, see, cos 2x has multiple formulas if you remember. There were 4 formulas. We'll use one of them. Alright, so what we'll use? We'll use cos 2x is equal to cos square x minus sine square x. Okay. Or you can also use cos 2x is equal to 2 cos square x minus 1. Because the plus 1 and minus 1 is going to get cancelled. That's much more easier if you use it that way. So what we are going to do now, we are going to take the same thing, that is cos 2x as 2 cos square x minus 1, and we are going to substitute. So we have 2 sine 4x into 2 cos square x minus 1 plus 1. The minus 1 and plus 1 gets cancelled. 2 cos square x into 2 becomes 4 cos square x into sine 4x. So this becomes the final answer, which we are trying to prove here. It's the same thing. Fair enough? Now let's do the fifth one, the last one. Last one is a bit different. Okay, we'll do the last one. See the fifth one, sine 20, sine 40, sine 60 and sine 80. Now, first thing, before you solve the fifth one here, of all the four values, we have one standard angle, correct? That is sine 60. So let's segregate, let's separate it. Okay, let's write down the value. Now, 20, 40, 80 are not standard values. Here we have to use the transformation formula. Now, till now, what did we do? We converted the sum or difference into product, correct? Sin C plus sin D, cos C minus cos D, all those things. Now, in this problem, we have product to sum or difference, whatever it is, right? So, first, what do? We take the sin 60. Okay, now first, you can write this one down. Sin 60, it's a standard value, right? Sin 60 into, the rest of it is what? Sin 20 into sin 40 into sin 80. Now, further, what we can do is we'll group sin 20, sin 40 together. You will figure it out why. Okay, you will figure it out why. We'll look into that part later. Alright. Now what do? So sin 60. What is the value of sin 60? Sin 60 is root 3 by 2. So we can write root 3 by 2 into these values, correct? So which is into sin 20, sin 80, sin 40. Fair enough? Now we have the formula sin x into sin y. Now 2 sin x sin y we know, right? What is 2 sin x sin y? If you remember, what is sin x into sin y? You are going to have cos function, correct? The difference in terms of cos. So we are going to make use of that one here. But the problem is, we have a 2. Here we don't have a 2. So what you do, you multiply and divide by 2. So this is one way. Or if you do not have 2, you can just make it as half of whatever that formula we have. Okay, it's easier if you just multiply and divide by 2. That means here what we are doing, you multiply this by 2 and you divide this by 2. Okay, multiply and divide by 2. So this becomes root 3 divided by 4 into 2 sin 20, correct? Sin 20 into sin 80 into sin 40. Now what you do, you group this. You take this. Now let's first write down the formula what we know. What is the formula of 2 sin x into sin y? This is nothing but minus of cos of x plus y minus cos of x minus y. Correct? This is the formula. Now we'll make use of this one. Now root 3 by 4, guys, just keep it aside. That's not really that important. Now what do we have is that you have to take this as cos of 20 plus this one. So minus of cos of 100 minus cos of 60. Okay, x minus y, you can take 20 minus 80, 80 minus 20, doesn't matter. This is what we have now, correct? So let's write it down. You have minus root 3 by 4 into cos 100 minus cos of 60 into, the next part is what? Sin 40, right? Cos 60 is a standard value, isn't it? So you can write this as minus root 3 by 4 cos 100 minus half into sin 40. Correct? Again, take LCM, minus root 3 by 4 into 2 cos 100 minus 1 into sin 40, and this 2 gets multiplied here. Correct? Now what do we have? Minus root 3 by 8 into multiply 2 cos 100 sin 40 minus sin 40. Here again we can apply the transformation formula, which is 2 cos x into sin y, right? 2 cos x into sin y. Now this is going to become one more transformation, that is sin of x plus y minus sin of x minus y, correct? So we'll do that one now. What you're going to have is minus root 3 by 8 into, now it is 2 cos x into sin y, right? So sin of, now what do we have? 100 plus 40. Sin 140 minus sin 60. 100 minus 40. This one minus sin 40. Correct? You will have minus root 3 by 8 into. Now sin of 140. Now can we use the allied angle formula? Now 140 lies in which quadrant? Second quadrant. So what we can write is, we can write this as sin of 180 minus 40, correct? Sin of 180 minus 40 is nothing but sin 140. So this minus sin 60 minus sin 40. No change whatsoever. What is sin of 180 minus theta? Sin theta itself. That means this is going to become minus root 3 by 8 into sin 40 minus sin 60 minus sin 40. Sin 40 cancels. What is sin 60? Root 3 by 2 with a negative sign, isn't it? So this is going to become minus root 3 by 8 into minus root 3 by 2. So what do we get the final answer? As 3 divided by 16. So the answer for this one is 3 by 16. Fair enough? Now, whatever problems we have solved so far, every problem is based on transformation formula, either from sum or difference to product, or the vice versa, product to sum or difference. Fair enough? Now, similar to these type of questions, see here we did sin 20, 40, 60, 80, right? They can also give you in terms of cos. Cos 10, 30, 50, 70 is equal to something, prove it. Or just the previous one, sin 2x, 2 sin 4x, like that you can also get in terms of cos 2x, cos 4x, like this. Now, all the problems are of the same type, in the sense the problem solving part is one and the same. Fair enough? Now, this or these are the problems or types of problems what you can expect from transformation formula. Fair enough? Now, in the next video, we'll discuss the next topic in trigonometry.